What is percent?
Isn't it a ratio expressed
Is
as a
what?
fraction of 100?
Is what?
A ratio expresses as a fraction of 100.
Okay, it's part of 100. That's correct. So when you talk about percent, percent is a number, it's a fraction. All right? It's a number that is part of 100. Now, let me give you an example. Let's say you have a test, and in the test has about 13 questions. Now, if you get 13 questions correct, how much percentage is that?
100.
Perfect. That's 100 because you got all questions correct. Now, if let's say you have 9 questions correct, how much percent is that? How do you find the percent? This same
Use
thing. Say that.
use nine question divided by 13.
Good. It's going to be 9 divided by 13 times 100. That means you're changing it to percentage. 9 over 13 times 100 will give you the percent. They will give you your scores in percentage time. So let's say, okay, how many questions did you get right out of 13? So I got 9 questions right. Okay, if I ask, okay, what's the percentage of that? That means I'm asking you, out of 100, how will you convert that? What part of 100 is it? That's when you divide it by 13 and get 100%, or 100 times 100. It's just like the same thing. You're in a classroom, and in the classroom you have 22 students, and out of the 22 students, 11 students are female and 11 students are male. In terms of percentage, it's going to be 50% because it's half and half. Altogether is 100%, but you divide it in half. You have one part is 50, another part is 50. Does that make sense?
Yeah.
Yes.
Okay. Now, if I go to Canvas, based on what we have in Canvas, I'm going to click on this calculating mass percent. In this case, you're given some sets of questions, and also you're given a formula. Now, don't be scared about this formula. All you just simply have to do is to know what the different parts of the formula represent. For example, when you say part is how much you're given. Okay? Whole was the total out of which that number was given to you. So, like the example I gave, you have a quiz, a test, 13 questions. That is the whole question. That is the whole. And then 9 is the part, because 9 is part of 13. So 9 is out of 13. So the formula is simply you divide the part by the whole and you multiply by 100. For example, here, it says in the school there are 1,540 girls and 1,632 boys. What are the percentage of girls and boys? Now, Hugh, if you're asked to find the percentage of girls and boys, how will you go about it?
Of girl and boy.
You do what?
Oh, so I can use the number of girl divided by for the number of boy and multiply 100 to find the number of girl, and to find a number of boy and to do the opposite way.
Now, to find the number, the percentage of girls, you have to first of all find the whole. What is the whole?
The whole is the boy.
Is the boys plus the girls.
Oh, the whole, I forget it. The whole is the total of of the girl and the boy added in total, right?
Exactly. So that is the whole. That's the total number. That's what goes in here. So in this case, it's going to be 3172. When you add the number of boys to the number of girls, you get 3172. Now, if you want to find the percentage of girls, you're going to divide the total number of girls, which is 1540. You're going to divide it by the total numbers of students, which is 3172. And then you multiply that one by 100. So that, in this case, this one is going to give you 48.6. Because all of them together is 100. Now, to get the percentage of boys, you simply subtract 48.6, subtract it from 100. That will give you the percentage of boys, because both of them add up together should be equal to 100. Do you get this first part right? Do you understand this part?
Yes.
Okay, what about Nyala?
Yeah.
All right, now let's apply it to chemistry. That is where the next example comes in. Okay, let me see if there's any example at the bottom. Okay, all percentage add up to 100. Now let's look at the other one. Let's look at how do we apply it in chemistry. So the second question here, you're given this. Okay, let me use this. Let's say you're given H2O. Okay, and you asked to find the percent of 5% of oxygen in H2O. Okay, if you asked to do that, and also you asked to find the percent of hydrogen. So find percent of hydrogen in H2O. The first step you take is what? Find the total, or find the total mass. You're going to find the total mass of H2O. In this case, the total mass is going to be the mass of hydrogen. The mass of hydrogen, which is 1 grams, times 2, which, because you have 2 hydrogen there, which will give you 2 grams. And then you're going to add it to the mass of, let me do it. You're going to add this to the mass of oxygen. The mass of oxygen is 16 grams. This will give you 18 grams. That is the total mass. Now, to find the mass of the percent of the percent of oxygen, you're going to divide what? Because the mass of oxygen in this H2O is 16 grams. So you're going to divide 16 grams by 18 grams. And then you multiply this by 100. That will give you the percent of oxygen in H2O. So if you do that, your answer will be 88.89%. So which means that the percent of the percent of hydrogen is going to be 100 minus that. Or if you want to do it the long way, you divide the total number of hydrogen in that compound, which is 2 grams. You divide it by the total mass, which is 18 grams. Then you multiply that by 100. So that will give you the percent of hydrogen in H2O. So in this case, it's going to be 11.11%. So all of them have to add up to 100. If it doesn't add up to 100, that means we made mistakes somewhere. So if you look at the example you're given here, you're given carbon dioxide, and you're asked to find the percent of carbon and also the percent of oxygen in that compound. So the first step is find the molar mass, and then find the mass of carbon, and also find the mass of oxygen, the total number of oxygen in that compound, and you divide by each one by the total mass and multiply by 100. That will give you your percent for each of those elements. Does that make sense?
Yeah.
Okay. Now let's look at this here. The same step, you could say NO2. So you're just doing it step by step. Enter the mass of nitrogen, the mass of oxygen. Remember, times 2, you have to multiply by 2. Okay? So here, you said the molar mass of oxygen needs to be multiplied by 2 because you have 2 oxygen there. And that's what you use in your equation. So, like I said, the trick here is to understand this. What is the formula? What does it mean? How to use it? If you understand that formula, all you just need to remember is how to plug it in, and that's it. You need another example?
No.
You don't need another? You don't need an example?
No, I already understand it.
You did what?
I understand it.
Okay. What about you?
I understand this now, Mr.
You understand a little bit?
I mean the whole thing.
The what?
I understand it, the whole thing.
Okay.